So indices is from the word index. It is actually the plural for index. Now index, which we can also say power, is a small number which tells us the number of times a number multiplies itself. So index or power refers to the number of times a number multiplies itself. All right. So if we have 2 raised to the power 3, this is just telling us that 2 is multiplying itself 3 times. So we have 2 times 2 times 2, and this is equal to 8. Also, if we have 5 raised to the power 3, this is equal to 5 times 5 times 5. And that is equal to 125. So basically, indices tells us that this number is raised to a particular number, and this means you are multiplying that number the particular number of times, or a particular number of times. Now there are 2 parts to indices. So we know that 2 raised to the power 3 is an example of indices or an index, and then 5, 3 is another index. All right, so 2 raised to the power 3 is not entirely an index. It is just the 3 that is the index. So the index tells us the number of times 2 is multiplying itself. So if we have a number, so we have 8 raised to the power 3. 3 is our index, or we can say power or exponent. And then the 8 is the base. So for any number expressed in indices form, we have 2 parts to it. We have the base and then the exponent. So if we have 2 raised to the power 3, our base is 2 and our exponent or index is 3. This is telling us that 2 is multiplying itself 3 times. So the exponent tells us the number of times the base is multiplying itself. Now, before you be able to solve any question pertaining to indices, you need to know the basic properties of indices, or let me say rules of indices. There are about 7 rules of indices. So we'll mention, or we'll go over them one by one. So the rules of indices. So rule 1, if we have a raised to the power m times a raised to the power n, that is, if we have 2 numbers and then the bases, which is the a, are equal, then we can add the exponents or the indices. I mean, when I say indices, you get a bit confused. So we can add the exponents or the powers. So since the bases are the same, we retain one base, which is a, then we add the exponents. So we have m plus n. This means that if you have 2 raised to the power 2 times 2 raised to the power 3, this will be equal to 2 raised to the power 2 plus 3. And that is equal to 2 raised to the power 5. If we have 3 raised to the power 2 times 2 raised to the power 2, we can't add the exponents because the bases are not the same. Over here, the base is 3, and over here, the base is 2. So for this, we cannot add because the bases are not equal. So that's for rule 1. Moving on to rule 2. A raised to the power m, all multiplying n, is equal to a m n, which means that m multiplies n. So if we have 2 raised to the power 2 all multiplying 3, this is the same as 2 raised to the power 2 times 3. And this is equal to 2 raised to the power 6. So that is it for rule 2. Rule 3. A raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. Again, if you have two numbers and the bases are equal and these two numbers are dividing themselves, then we can subtract the powers or the exponents. So a raised to the power m divided by a raised to the power n can also be written as a raised to the power m over a raised to the power n. And it's still equal to a raised to the power m minus n. So again, if you have 2 raised to the power 2 divided by 3 raised to the power 2, we cannot subtract the exponents because the bases are not equal. But then if we have 2 raised to the power 2 divided by 2 raised to the power 3, then this will be equal to 2 raised to the power 2 minus 3, which is equal to 2 raised to the power minus 1. So rule number 4, a raised to the power 0 is equal to 1. This means that any number raised to the power 0 is equal to 1. A can be 100, A can be 9, A can be 1,000, whatever A is. If it's raised to the power 0, it is 1. So 2 raised to the power 0 is 1, 3 raised to the power 0 is 1. And because of this, we can say that 2 raised to the power 0 is equal to 3 raised to the power 0. And this equation is valid because 2 raised to the power 0 is 1 and 3 raised to the power 0 is 1. And 1 is equal to 1. So let's take note. Rule number 5. A raised to the power minus 1 is written as 1 over A. So if we have 15 raised to the power minus 1, it is equal to 1 over 15. Rule number 6. A raised to the power 1 over 2 is equal to the square root of A. So if we have A raised to the power 1 over C, this is equal to C root A, or the C root of A. A raised to the power 1 over 3. Our C is 3, so we have the cube root of A. So that is it for rule number 6. Now rule number 7. A raised to the power P over Q can be written as A raised to the power P times 1 over Q. Now 1 over Q can be written as Q root of, then we have A. So if we have 3 over 2, we can rewrite this as 2 raised to the power 3 times 1 over 2. Now 1 over 2 can be written as the square root of, so we have square root of 2 raised to the power 3. That will be all for the rules of indices. So now, with this being said, we can also express whole numbers as numbers with indices or bases or powers. So if we pick a number like 8, now 8 can be written as 2 times 2 times 2, and this is equal to 2 raised to the power 3. Or we can use the old method, the method we know from class 6 and JHS. So if we have 8, we use a number tree, so we have 2 and 4. So 2 times 4 will give us 8. And then for 4, we have 2 and 2. So this will be 1, 2, 3. So 2 raised to the power 3. If we have 27, we know that 3 times 9 will give us 27. And then 3 times 3 will give us 9. So this becomes 3 raised to the power 3. So we can express whole numbers as numbers with indices or powers or exponents. So with that being said, let's pick some examples or questions under indices. So indices is all about knowing the rules and applying them. So first, let's look at this question. So we are simplifying 27 over 64 all raised to the power minus 2 over 3. So first, This can be written as 27 raised to the power minus 2 over 3 all over 64 raised to the power minus 2 over 3. Now we can express 27 as a number with an exponent or a power. So 27 can be written as 3 raised to the power 3 all multiplying minus 2 over 3. Then all over 64 can be written as 4 raised to the power 3 or multiplying minus 2 over 3. Now here, so since we can multiply this and this, we know that AMN is equal to AM times N, which is equal to AMN. So 3 raised to the power 3 minus 2 over 3 is equal to 3 raised to the power 3 times minus 2 over 3. Now, if we have 3 times minus 2 over 3, this 3 can cancel this 3. So the same thing here, we can cancel this and this. So we'll get 3 raised to the power minus 2. Also, 4 raised to the power 3 multiplying minus 2 over 3 can be written as 4 raised to the power 3 times minus 2 over 3. And this 3 will cancel this 3, so we'll be left with 4 raised to the power minus 2. So we have 3 raised to the power minus 2 divided by 4 raised to the power minus 2. 3 raised to the power minus 2 form, our rule 5, can be written as, so 3 raised to the power minus 2 can be written as 1 over 3 raised to the power 2. So 3 raised to the power minus 2 is equal to 1 over 3 2 divided by 4 raised to the power minus 2 can be written as 1 over 4 raised to the power 2. This will give us 1 over 3 raised to the power 2 is 9 divided by 1 over 4 raised to the power 2 is 16. And this is equal to 1 over 9 times 16 over 1, which is equal to 16 over 9, or 1 whole number, 7 over 9. So we can simplify. So we have simplified this to this or this. So if you pick another question, x raised to the power 5 is equal to 1024. And we are being asked to find x. So first, we are saying that a number raised to the power 5 times is equal to 1024. So we are finding a number that when we raise it to the power 5 times, that is when we multiply it by itself 5 times, we should get 1024. So we know that 1024 is equal to 4 raised to the power 5, which is 4 times 4 times 4 times 4 times 4. And so we can say that x raised to the power 5 is equal to 4 raised to the power 5. So what number multiplies itself 5 times to give us 1024? And it is 4. 4 multiplies itself 5 times to give us this. So that's x, or that number is 4. So therefore, x is equal to 4. So we are not applying any rule of indices here. We are just expressing this number as a number with indices, and then we are finding the x. So that's all we did for this part. Now let's pick another question. So 4 raised to the power 2 minus x times 16 raised to the power x plus 1 is equal to 64. So first we can express 16 and 64 as 4 raised to the power a certain number. So 4 raised to the power 2 minus x times. Now expressing 16 in the base of 4 is 4 raised to the power 2. Since 4 raised to the power 2 is 4 times 4, and that is equal to 16. So 4 raised to the power 2, all multiplying x plus 1. So x plus 1 is equal to 64 can be written as 4 raised to the power 3. This is just expressing the numbers as numbers with powers or exponents. So we have 4 raised to the power 2 minus x times 4. Now we know that a n m is equal to a n times m. So 4 2 x plus 1 is equal to 2 multiplying x plus 1. This is equal to 4 3. So we have 4 2 minus x times 4. 2 multiplying x, we have 2x plus 2 multiplying 1, we have 2. Is equal to 4 3. Now from here, from our left hand side, you can see that the bases are equal. And then from our rule of indices, if the bases are equal, we retain 1 and we add the exponents. So we have 4, then 2 minus x plus 2x plus 2 is equal to 4 raised to the power 3. So first, let's simplify the exponent. So we have 4 raised to the power 2 minus x plus 2x plus 2 is equal to 4 raised to the power 3. So this gives us 4 raised to the power 2 plus 2 will give us 4. And minus x plus 2x will give us positive x is equal to 4 raised to the power 3. Okay, let me add one extra rule of indices. If we have a raised to the power m equals a raised to the power n. Since the bases are equal, so we can equate the exponents. So therefore, m should be equal to n if the bases are equal. If we have 2 raised to the power 2 equals 3 raised to the power n, we can't say that 2 is equal to n because the bases are not equal. So for this one, 2 is not equal to n since bases are not equal. So we can add this rule to our rules. Now, since the bases are equal, we can equate the exponents. So we can say that 4 plus x is equal to 3. And we can find x by making x the subject. So our x will be equal to 3 minus 4. So x is equal to minus 1. So we know how to use the rules of indices to simplify an expression. Now we also know how to use negative and fractional indices. So let's pick one with a fractional index. So if 16 is equal to the cube root of 2 squared, find the value of n. From rule 6, you are saying that a raised to the power p times 1 over q is equal to q square root of a raised to the power p. So if you have the cube root of 2, according to our rule of indices, this will be equal to 2, then p, which is 2, times 1 over our q, which is 3. And this is equal to 2 raised to the power 2 over 3, because 2 multiplies 1 over 3. So then we can say that 16 is equal to 2 raised to the power 2 over 3. No, this is 16 raised to the power n. So so we are finding n. So first, we need to express 16 as a number with a base of 2. So 16 is 2 raised to the power 4, or multiplying n, is equal to 2 raised to the power 2 over 3. So 2 raised to the power 4 is equal to 16. Now, if we have, from our rule of indices, if you have a, m, n, this is equal to a, m times n, which is equal to a, m, n. So 2 raised to the power 4n is equal to 2 raised to the power 4 times n, which is equal to 2 raised to the power 4n. So 2 raised to the power 4n is equal to 2 raised to the power 2 over 3. And from our last rule, if the bases are equal or if the bases are the same, we can equate the exponents. So we can say that 4n is equal to 2 over 3. Now to make n the subject, we can divide 2 by 4. So we divide here by 4 and the whole of this by 4. So 4 cancels 4. You'll be left with n is equal to 2 over 3 all divided by 4. And this is the same as 2 over 3 divided by 4 over 1. So we have 2 over 3 times 1 over 4, which is equal to 2 over 12. 2 goes into itself 1 and it goes into 12 6 times. So we have 1 over 6. So therefore, our n is equal to 1 over 6. So we know how to simplify expressions involving indices. We know how to use the rule of indices. And then we know how to use fractional indices and negative indices as well. This brings us to the end of our tutorial on indices. I hope you spend time to solve more questions to be able to understand it better using what I've taught or what you've learned in this video.